So it's very quick. I kind of had to toss that up a little bit because I didn't want to affect how the arrows were flying. So what occurs basically is it gets into the code, it draws the first line, and then it waits. And it doesn't. The way it does this is it defers the rest of the code that it was going to execute for like 50 milliseconds. So let me find the first one. So this first one here, this bit right here, that draws the yellow line. Let me see if I can capture that right. Okay. So that first bit draws this yellow line that shows us where we're pointing and where we're aiming. And then next frame, which I should take out of there, but it's Sergey's code. I borrowed that from his library. It's basically a timer performed with delay, and I wait 400 milliseconds, and then I do the next step, which is I remove that yellow line. This may be a little bit hard to see. Let me zoom in here. And then I generate a new vector, and I do some manipulation on it, and then I draw a new line, and I make that 3 pixels wide, and I set it to red. So now if we, there we go. So that's the next step. Now we got a red line. Now things are a little bit out of sequence here because I paused and released, and my arrow already hit the character. But so then this shows us the velocity of the arrow and the direction and magnitude. Magnitude being the length of the vector. And then moments later. Okay, so this part we had to do in advance. So we have the arrow, it's flying. So the arrow is flying the whole time. We're drawing these lines. And then half a second later, what do I do here? I print out a little debug message to the console. And 1 second later, I destroy the line. So
basically, if you were doing this without explanations involved, you wouldn't need all that, right? You wouldn't need all that debug stuff unless, of course,
I wouldn't need any of that stuff. Basically, what I want to be able to people to be able to do is walk through this code and sort of visualize the concept of what a vector is and what it represents in a sense where they can actually see something instead of just trying to go from, okay, I got a vector and somehow that becomes the velocity. What does that mean?
Yeah.
So, as I'm sure that Stephen will agree with, it's very hard sometimes to demonstrate to people these principles if they're not familiar with the fundamentals. So, having said that, now that we're shooting arrows, let's deal with collisions and killing the characters. But before we do that, what I've done is I've made a small change this week just because I think it's more pleasing. In fact, let me turn off the debug code here just for giggles so we can see this a little better. And give me 2 shakes here. There it is, hybrid mode turned off. Can't see me typing. It's probably a good thing because I always mess up when I'm typing on the show. But I'm basically turning off the hybrid mode, and then I'm going to go into common, and I'm going to change the number of enemies to 10. And I am going to go into player maker, and I'm going to turn off the do debug. That's going to be false, and hopefully if I know how to type, everything will be working now. Okay, good. So we're back to what it should look like. I'm just going to play it for a bit here, but explain what's going on. So one of the things that I wanted to do was demonstrate that for a desktop game, we have a lot more latitude with regards to how many things we can have going on, how much content we can have on the screen. With a mobile game, you kind of have to be careful. You can't have too many things rendering. Now, I'm not doing anything heavy duty yet, but this could quickly get out of control. The thing you're seeing is that I'm shooting these enemies, and their bodies are not being removed from the screen. They're just accumulating, which is one of those things you commonly see in shooters, is that the guys you kill hang around for a while. And the way I've got this set up is every time you kill a zombie or one of these enemies, it goes through its knockback animation. So let's just get one where you can see it. It gets knocked back and disintegrates. Oh, and I died. But that kind of ruined the whole thing there. And then once it's done disintegrating, its physics body is removed, and it just sits there for 100 seconds, and then it slowly fades out and is removed from the scene. So for 100 seconds, we can have this accumulation of more and more bad guys. For me, the scene is still very visually boring. I mean, we've got a very boring background. We don't have any additional content in the scene. It's just us, the bad guys, and our arrows and the ground. But this is how we start to layer on complexity into our game to make it more interesting as far as visual or aesthetics go. And we can afford to do so because a desktop machine has all kinds of horsepower and memory. This is no challenge whatsoever. I could just have thousands of these things and it would just not be a problem. So today, if I can pause before I die, what we want to talk about is what happens when the arrow hits the character, the enemy, and just that whole bit that we saw right there. So let me go ahead and dial in to the code that does that. There's two places that we're going to look at for this. First, we're going to look at the enemy manager, which is our piece of code that generates the enemies and puts them on the screen and makes them start walking towards us and keeps them targeting our character, following our character. And the important bit about this is that, let me find it here. When we create the character, when we create the enemy, I add two methods to the enemy. I add one called self-destruct, and I add one called delayed self-destruct. Now, this is the one that I added today. In fact, you can see I haven't even renamed some of the comments. But basically, they do a similar thing. Self-destruct will cancel the currently playing transition. If the enemy is still walking forward or moving to a point, we want that to stop. So in other words, when we kill this enemy, let me restart this. These guys are walking towards us. As soon as that arrow hits him, we want it to stop moving. In fact, what we want is we want the transition to just say, okay, I'm done. I'm not going to try to move it in the direction it's moving. Now I'm going to let the physics take over, and the physics will do whatever. So this is kind of one of those weird cases where I've combined physics and transitions, and you have to be really careful about that, because if you have the transition code doing one thing and physics trying to do another, you never know who's going to win. Typically, I think transitions win in the end, but you're going to get this really strange behavior where the transition may be trying to move your content in one direction and physics are trying to move it in another, and it just looks wrong. So, but because I wanted to use transitions for simple movement, and yet I still wanted to have physics in the game and use it for things like knockback, as soon as the collision occurs, I need to cancel the transition that's moving this graphic to from right to left and let the physics calculations take over. So when the collision occurs, I call either self-destruct or delayed self-destruct, and the first thing I do is I call transition cancel on the graphic, on the display object, and that kills any transitions that are on it, and they no longer affect the movement or the shading or anything else those transitions were handling.
One question are physics only for collisions, or you actually making something with physics bodies like applying velocities and other stuff?
Yeah, so to answer your question, I am using physics for collisions and knockback. Now the knockback may be a little subtle, and I can dial it up a little bit so you can see it more clearly. We had a discussion on this a few weeks back, but a happy accident occurred when I was coding this up. I had all this code in place, and I simply canceled the transition, but because I had set the body, I had been using physics too, what I got was this knockback, but it was extreme. Like I hit the zombie and the zombie got knocked off the screen. I'm like, oh, that's not right, but it's kind of cool. Because what you really expect is a little bit of, you want that character to get knocked back. So this is, right now it's really subtle.
Okay, nice.
Very slight amount of
you, for anyone who is watching, if you want to use physics for collision only and not to have this weird behavior when physics fights collisions, and you can just set your physics body as sensors.
Right, as a sensor.
Mm-hmm.
If you set it to be a sensor only, then what you're going to get is the collision detection, but not the response. So I think we said this on prior shows, but physics are, let me say it correctly. Physics collisions have two parts. They have the detection and they have the response. The response is all the physical bouncing and movement and all that stuff that you would assume to go with physical bodies. Whereas the detection is the part that we use in our code to see if a collision occurred and do something specific about it in our code.